Hey, Yaroslav, welcome back.
Yeah, thank you.
So we had some trouble with the Starlink last time.
Yes, uh, that I think. Well, it was after I read some announcement that there were like 60 new Starlink satellites. They went
Hmm.
up, and I think it was maybe recalibrating or something. But suddenly, uh, the connection was dropping like each few minutes, and
Uh-huh.
like few days before that, it was keeping up all day, like with few like occasional uh, occasional dropouts because of the occlusion. But yeah,
Yeah. So how
so
fast was it usually? So the Starlink.
usually there was around 200 megs
Wow.
download, 50 60 megs upload.
So it is a really good actually.
It's really good. It's like, and if the thing is that I was at the like recreational place, so it
Hmm.
was not my place, so I had just limited options where to put the Starlink antenna.
Hmm.
But if you can find a spot where you have no obstructions, I think that should be really good. So I surprisingly, it needs to see the northern sky, so it's inclined to the northern part
Okay.
in this latitude. That means like
Hmm.
Europe, basically. I thought
Okay.
it would be more. It would require like southern view,
Hmm.
but it's not the case. It requires northern view.
And how big is the antenna?
It's like, I don't know, 40, 50-ish, 50 centimeters by like 30.
Okay. And you need a battery or power
Mm,
cord?
no, it's a power cord. So it's powered from the router. So you get like a router, the small box,
Hmm.
and you power the router, and from the router it takes the power to the antenna.
So it's actually
It's,
good. And how expensive is it
it's
roughly?
roughly, it costs me to get the hardware around 500 euros,
Hmm.
and then I'm paying RV edition, so I can take it anywhere in Europe.
Hmm.
So it's not, and that costs around 120, 115 euros
It's not that bad
approximately.
either. Actually, it's not as bad. I would say it's
No, no,
reasonable.
no. And if you fix it to your address, you would pay something like 70, 60, 70 euros maybe.
And the bandwidth is included, so it doesn't matter.
Yes, yeah, it doesn't matter. It's like whatever you use.
Okay, cool.
So yeah,
So I would say Starlink is good now for Java developers, right? So
yeah. Actually, also the latency is not so bad.
mhm.
Like I was connected over Starlink to like remote servers. I was doing like development. I had like remote VS, remote shells, and yeah, and
Mhm.
I was productive. So I was not actually held back by the connection. So
Mhm. So what you would like to talk about today is bitrace and Java
mhm.
profilers in general, right?
Yeah.
So I took a look at the bitrace, and so it looks good. So what's surprising actually that you use Java JProfiler, Java profiler to optimize bitrace.
Yes. Uh, Honestly, it was a long time ago.
Okay.
so so that and JProfiler was really nice to give me a free license
Hmm.
for the product. At the time, I was also well. The problem was that I used to work on NetBeans Profiler, so I wanted to use NetBeans. But at the time, NetBeans was donated to Apache,
Hmm.
and yeah, I did. Honestly, the quality. Yeah, you can feel the difference in the quality when you have like full corporation backing up development and testing everything.
Hmm.
So now it's more like open source ish, and if somebody has time to contribute, and there are not that many people with the knowledge to contribute to Profiler, so the Profiler started lacking compared to commercial tools.
Hmm.
So that's why I decided to use JProfiler.
Hmm.
And well, today probably I would go with Async Profiler because
Hmm.
that's kind of state of the art for profiling. It's I haven't been using NetBeans Profiler for a long time. Like,
Yeah, I also didn't, but
so-
okay, no problem. But you
Yeah.
mentioned you suggest another profiler. Which profiler you suggested?
An async profiler.
Async profiler. Is it a commercial one?
No, it's open source.
Mm-hmm.
It was created by Andrei Pangin. He might be also a really good tip for a guest. He's very interesting, very interesting person in Java and profiling space.
Mm-hmm.
He also used to work at Sun. I think he was. I might be wrong, but I think he was also involved in the Sun Studio performance analyzer. And so he's got long history of working in the performance space in Java.
Async
And-
profiler, 6,500 GitHub stars. It's incredible.
Yes. It's really neat tool. Like it's using async at call trace, which is unsupported API for getting stack traces in a way which is not safe point biased, and it was actually introduced for this Sun Studio performance analyzer way back as kind of like Sun internal contract. But you still can get to it with some tricks like loading the library and looking up at the symbols, and then you go to the symbol and then you start using it.
Mm-hmm.
And it basically allows you to drive the sampling profiler from a signal handler. So you can use something like iTimer or timer create, or nowadays you can even use like perf events open, which is like the most precise sampler driver, because it's coming from the Linux kernel. Well, talking about Linux, right? It's coming from the Linux kernel, and you can tell, like, you can set it up in a way that, okay, so if the thread used like 10 milliseconds of CPU time, then deliver the signal. But you can also tell it like if this many CPU ticks were used. So you can, instead of like going to time, you can base this on the actual CPU cost. And there are like many more this perf events types, like cache misses.
Okay, so let's start with profilers, because we are already deep into the weeds, right? So what you mentioning right now is how precise a profiler can be, right? So
Yes.
And this async profiler seems to use a low-level functionality, and what I'm interested in business application is mostly a rough idea what is slow. So I'm not interested in ticks, but to identify what's the problem.
Yeah.
And you are looking at from profiler perspective to hyper optimize something, right? So there are two different use cases.
Yes.
Would we use different profilers for it? I would say, for my, just like an overview profiler, and in your case, you really, like CPU level Linux kernel profiler.
Yes. So it's like you need to optimize the profiler.
What you would
for the use
suggest
case.
for a business profiler? Like a rough idea. JVisual VM, is it enough?
If your use case is to find like low hanging fruit, something like really some omissions, then JVisual VM is okay. Like internally, it is using get all stack traces from JMX, and that means that you will have you will be collecting the stack traces only at safe points. So that means like you will not see any details about loops. Inlining can mess it up. Like you might not see like short inline methods. It will be attributed to the method which is doing the inlining. So, but if you know the shortcomings and you are okay with that's pretty safe bet.
But you are mentioning the sampling, right? So not the
Yes.
profiling, so the sampler. Profiler is slower. This is actually the same what NetBeans profiler.
Yeah, okay. Yeah, you mean the instrumenting profiler, right?
Yeah.
Okay. Well, I had a talk like many years ago, at the same time as Nitsa and Vaka, like rambling about what the profilers are getting wrong, and this is one of the issues I have with the instrumenting profile. Although I was working on instrumenting profiler before, that by instrumenting the code, you are basically changing the execution characteristics of your application. So you might end up profiling something which is different than what you would get without the profiler. So that's the main problem I have with the instrumenting profilers. Having like the slowing down of the application, it's not so bad if you are doing the profiling as a part of the development process. So like you run some experiment and you collect profiles and you analyze it. If you want to run the profiler in a continuous manner, like what we are doing in Datadog, like we have always on profiler, then the instrumenting profiler is also not very suitable because of the overhead, unfortunately. So currently, what I see is like almost everybody is moving to sampling profilers. Like the instrumenting profilers are not, they are not getting any real traction. I know the YourKit profiler. They also added like profiling mode based on the async get call trace, so it's similar to what async profiler does. Plus all their like specific commercial extensions, like they have all those probe points where you can integrate with the frameworks. So like you can start profiling when you like start processing request, for example, and then you stop the profiling when you end the request, and you can collect like very focused profiles. So so that's about it.
So I use this visual VM, the instrumenting profiler, and
Yes.
the problem was it was slow and cost lots of memory, but it was somehow stable. So if you dedicate the memory, so I even profiled the entire Glassfish or Payara, I cannot remember. So with eclipsing everything, and it actually worked, but was really slow. Yeah. And the sampling profiler, it was good enough to identify the rough hotspots.
Yes.
And this is what I use. I also use the J profiler. So this is, I think it was Citraca back then, the company behind, as I remember. Yeah, and YourKit, I also use YourKit. So I was just curious about your opinion. When async profiler is also interesting. And you're using async profiler still?
Yes. Well, most of the time I'm using async profiler together with the JMH. So I write the micro benchmarks, and JMH has a like built-in integration with the async profiler, so it can run async profiler on the micro benchmark. So it's really cool.
So JMH, this is interesting because I also use JMH. I misuse JMH to write tests, performance tests for for end-to-end, actually. So what I used JMH, and I launched from JMH, a HTTP client which connected to the server, and I got nice statistics. And I use it as a hack because this JMH, this is Java Micro Benchmark Harness, is part of OpenJDK. And there was less discussion with my clients regarding, third-party dependencies and frameworks. Like, look, this ships almost with Java, so let's take it. And it was actually, it is annotation-based. It is one Maven plugin, and it is, I would say, almost a secret tool, right? It works actually very well. But as I said, I mostly use it for end-to-end. You use it to test algorithms?
Yes. So that's my main usage, is to test the low level, like the performance critical parts. But I must admit I also use it for another purpose, not Btrace, but I use it also in a way like you do. It's very convenient. I know it was not meant to be used like that, but it's very convenient. Does the job really well. So.
So you can for instance specify thread whether this is one shot, multiple shots, right? So there's you can specify the how to call it with annotations, the mode in which it operates. So it's really convenient. Okay. What I also was curious, you used in your Btrace project. I just lost the tab. Btrace GitHub. You used JC collections, so high performance collections, right?
Yes.
So you used JC Tools was called.
JC Tools, yes.
And JC Tools and the collections was called HPPCRT.
Yes.
So the HPP CRT is somehow it was archived, so it is no more operational. It seems like it. So why you use the HP CRT?
Because the HPC CRT they were providing pre-prepared primitive collections, and in Bitrace there are many places where I need to have like maps indexed by integer, for example, or sets of longs or.
Okay.
And if I do use normal collections, then everything will be boxed and unboxed, and it becomes quite terrible performance wise.
What means terrible? How fast or slow is it? Roughly.
Well, when you use it was adding like noticeable like several hundred nanoseconds. If I remember correctly,
Okay.
I mean, yeah, but it's the problem is that it was it was in a code which gets inserted into like user application. So I'm trying to be like as lightweight as possible.
Sure.
And also it was adding like several megabytes of allocations per second when you were like instrumenting over like all JDK classes. I mean, yes, these are like the corner cases, but you would be surprised like how many times people are doing strange things like when they can.
No, this is complete different use case. What you are doing is if you're building Bitrace, which is called a lot internally, and I'm building mostly servers, from outside.
Yes.
So, but I was laughing because I would try in one meeting to say, well, if we introduce the collections, we can be faster in several nanoseconds, and we have problems in almost minutes,
Yes.
This was just, but I'm absolutely with you. I guess. It would accumulate, right? So if you are not cautious with that, and you call it, several hundred or several 100,000 times per second, maybe even, then it's a noticeable difference. This is
exactly. And you're affecting your GC, so then you might start actually causing unexpected pauses depending on the GC type. So it's like I know they say like premature optimization is root of all evil, but when you are working on low-level libraries, then it's like you rather be really cautious because the design choices they make big difference at the end, and it's very difficult to go back and change everything in the library which is used. Like if nobody's using it, that's cool, but then it doesn't make sense to work on that, right?
Sure. So you use the HPP CRT just to have primitive indexed collections, right? So
yes,
you wanted,
yes.
Okay. So this would because if you access the collection, you don't have to create an object for it, which is which is better. Then there's a JC tools which are also used. This is the JC tools. This is actually quite popular. 3,500 stars.
Yeah.
And this is Java concurrency tools for the JVM. So the question is why you use that?
I needed I need to have for the communication in the Bitrace, I need to have something very fast which can transfer data from the instrumented application to the client and so on, and also like the communication channel, and like doing something like over synchronize, like if you do like synchronization or something, then it becomes noticeable slower. JC tools they provide really good implementation of especially concurrent queues, and they have multiple flavors of those queues, so you can pick for your particular use case. Like you have multiple producer, single consumer. So that's I'm using this queue for when many threads are actually posting results for the one thread which communicates with the other side to pick up and send it over. So I have multiple producers which are like sending really concurrently the data for the single consumer to take that and serialize it over the network. And it makes a lot of difference. Like it is specialized for this particular use case, so it is mostly lock free. Yeah, the consumers are completely independent, so you are not affecting one thread by sending something heavy from the other thread. There's like I have like single producer, single consumer for things which need to be communicating one to one, and yeah, as I said, this is based on the use case, and when you pick like the algorithm which is actually tuned for this use case, it's much. It's very noticeable difference. Like when you use something like Concar, there's like blocking queue, which comes from JDK, it's okay. Like, but if you are moving in the area of like hundreds of nanoseconds to microseconds, then you start noticing that it's yeah, it's like
how much requests per second and how much data are you sending?
This depends on the application and the if you put instrumentation in something like what I saw, something like getting a list element, like when you instrument array list get, or if you instrument like all subclasses of list get, and then you run the application, which is really like intensive and running on many threads, so you will be doing it as fast as the application can do it. So you can have like millions per second, no problem, if you have enough cores. So I saw that on like 64 core machine, and then you really go up over tens of millions of messages per second.
So the bitrate already handled 10 of millions of messages per second.
Yes.
Okay, that's interesting. This is, of course, this complete different world because you're very low level, and this also makes sense that if you use, something like the Java concurrency tools for the JVM, and you can be 20% faster or even more, then I mean, just go for it. So it's interesting. It's a very, very popular project actually.
Yeah.
This is
it's coming from the high frequency trading implementers. So these people they need to have like as low latency as possible. Like they need to have really fast algorithms there. So
this would be my next question, because maybe you are aware of the LMAX London exchange is called Disruptor.
Yes.
This was like a very fast ring buffer almost, right?
Yes.
Have you looked at that back then?
Yes.
Or?
Yes. I was deciding whether I should try Disruptor or then JC Tools. Honestly, I went for JC Tools because I had multiple patterns of usage.
Okay.
And the Disruptor is, if I remember correctly, is really optimized like for multiple producer, single consumer. At least the original one. Maybe there are some other implementations now, but the JC Tools is very, very similar to that. It's using like similar approaches.
Okay.
And it provided me with like different choices which were fitting exactly my use cases. So
yeah, exactly. This is what JC2 are saying. There's like they are starting with the explanation. So they have SPC, single producer, single consumer, multi-producers, single consumer, single producer, multi-consumer, and multi-producer, multi. So one to N, N to one, and N to M. They localized, bounded. So really interesting.
Yeah.
And it's also still active, the project, which is amazing.
Yeah. Nissan Wakard is still maintaining it. I think, if I remember correctly, also Francesco Negro is active there. But yeah, I mean, there are not many new features coming in, but they are still maintaining, fixing bugs, slightly improving stuff, and it's stable. So that's really nice. That's still stable.
Java has actually an incredible ecosystem, right? So if you
it's one of the main things I like about Java, that the ecosystem is as you said, it's incredible. It's like.
So Nissan is still, working on it heavily.
Yes.
Nissan Wakard is the name of the main developer.
Yes.
And which is, I mean, incredible. This is an older project, and it's still popular. Yeah. So the next thing is ASM. You're using ASM, right? And I can imagine why, but you maybe need the hooks, right? So this is manipulated a little bit the bytecode.
Yes. So yeah, that's how you do the instrumentation and tracing. Like I need to generate the bytecode, which will get injected. I need to modify. Well, actually, I need to modify the bytecode of existing methods, so I can insert the callbacks to btrace. And doing this by hand, it would be immense pain. So
yeah,
I know we in an admins profiler, we had to do this in the native code, basically doing the instrumentation, and it was like we had to restrict the instrumentation into very, very, very simplistic operations. Like doing anything bigger, it was terrible. But with ASM, I would say it's a breeze. Like it's very, the ASM has very well thought of API. I know some people are really like disliking the visitor pattern. Now they say it's like, it's old school and obsolete and whatever, but it fits extremely well with the bytecode. And I would say like the main advantage is that it allocates almost nothing. Like you are able, so if you are using ASM in this like visitor pattern like manner, you can analyze the bytecode without incurring a lot of overhead in terms of like memory structures, because you go one section after another. So and then you can and what is another thing is that while you are actually analyzing this and you are able to generate the instrumented code such that you don't need to have any look back information. Like if it's okay, let's call it stateless. So if you can generate the stateless instrumentation, then you can do it in one pass. You don't need to do like one pass analyzing and then another pass injecting the code. You can do it in one pass. And actually, btrace started like this. Like btrace was doing like one pass instrumentation, but then I added some more advanced modes for specifying where you want to inject, what you want to inject, and that actually that requires this state or look back. So you need to know that you saw something before you are trying to inject particle code. So in btrace now, I'm using a mixture of the visitor mode and they call it DOM, like what is domain object model?
Document object model, yeah.
Yes, where actually the class is being transformed from bytecode into graph of objects. So you have like a class node object, and inside the class node you have field nodes, and you have method nodes, and inside the method nodes you have like instruction nodes. It takes more memory, but you can do much more sophisticated instrumentation. Like you can reorder nodes, you can insert new nodes there, you can look up the nodes, you can like basically jump around the class, which is really powerful.
So now we have everything to understand btrace, right? So what happens is, so I tell btrace, this is my program, and I would like to, how to call it, profile it? How would you call it? Or monitor?
I would say monitor, or I would say probe. It sounds funny, but probe it.
To probe it?
Yes.
And then, okay, I specify somehow, so we'll talk about this in a second, what to profile or what to probe. And you will use ASM and inject a hook into the code.
Yes.
And the hook will gather information and pass it with JC tools, and using collections for the high performance collections for caching or whatever. And this JC tools ships the data somewhere else. Yes. And the question is where. Where did I ship?
So the Beatrace started as a like command line tool, which has client and server. The server is running inside the probed application, and in this mode, it will send it back to the client. Like client is listening on a socket on commands, and the commands are like print this value. So then it will take the value and it will print the value. So it works in kind of synchronous mode. You need to open the connection to the server. You will start the instrumented code there, and then you will have the output scrolling in your terminal window.
So this is now interesting distinction. So Beatrace is interactive.
Sorry, Beatrace is
Interactive.
Yes. So that's the command line tool. Like you can kind of interrupt it when you press Control C. You will get like small menu. What you can do, like okay, there is a limited interaction. You can send a signal to the probed code, which is called event, and you can have like named event and unnamed. And for these events, you can specify the handlers in your probe code. So you can do something like you can how it can be used. You can be collecting some statistics, but you don't want to be printing out the statistics all the time because it's like generating all the string, the textual information. It can be costly, but you can define this event handler for something like it can be named like print statistics, and then you via the Control C and then go to the menu and send the print statistics event to Beatrace. It will actually grab the collected statistics and will generate the textual representation of that, send it back to you. So you can kind of like it's lightly interactive. I've been thinking about getting it like much nicer command line interface based on something like ncurses or something like where you can have multiple probes running in different tabs and all that jazz.
Okay.
But not yet.
So if I install Beatrace and I would like to, let's say, test my small Quarkus application or whatever, I will have to tell Beatrace what to look at, right? How I do it.
Well, you need to. So there. First, you need to have the probe program. So you need to write the small program, or you can grab it from the samples. Like in Beatrace, also in the distribution, there is a samples subdirectory, if I'm not mistaken, and you can go there, or from the GitHub. There is there are samples also in the wiki, and you can just grab one of those. But then you need to adjust it. So you are actually you are intercepting the correct methods. Like you need to use the package name or the fully qualified class name. So that's one thing. So you need to have this ready, and then you can list your Java processes via JPS, for example, and then you tell Beatrace connect to this process. So that there is like command line invocation where you do Beatrace, then you do the PID or the name. It's similar to what JCMD does. In JCMD, you can use the name of the application as reported by JPS or JCMD. Like for example, you know that means that you know the anagrams.
Yeah.
So that's my go-to. So I would do like a Beatrace, anagrams jar, and then the path to the probe file.
Yeah. And what I see right now is from the wiki is a class called all methods with a Beatrace annotation on it.
Yes.
And there's one annotation on method where I can specify the class and method. So
yes.
So what I can do, I can have a regular expression which specifies which classes I'm interested in and which method I'm interested in, right?
Yes. So this is similar to AOP cut point.
Yeah. This is what I wanted. I thought actually you rely on on AOP point cuts, but this is nicer because what I could do, I could say all the classes from JSONB or all the classes from JAX-RS, and then I get all the classes instrumented, right?
Yes, And this is one of the modes. Like you can do like method instrumentation, and you can specify you want to instrument method at the entry, at the exit. You can also you can specify like you want to do the instrumentation before, for example, before return or after return also. So you can like add something which will get executed after you actually call the return. And there are more modes. Like you can intercept calls, like method invocation within a certain method. So it's kind of two level. So you would specify the method and the class and method where you want to scan for the method invocations, and then you have like you will specify kind call. It's like instrumentation kind call, and for that kind call you can also specify that, okay, so I want to instrument calls to, I don't know, string is empty or something. Like you can specify like what particular method invocation within this method or those methods, if you specify it by the regular expression, will get instrumented. And on top of this, you can intercept things like setting array elements, reading array, basically like everything that is in the bytecode, you can more or less intercept. Like you can intercept synchronization. So.
So what I understand is that btrace is an agent, right? So you have to install the agent to the JVM.
Yes.
And then if the agent is installed, I can run the btrace program or binary and specify a script, which interestingly is a Java code script.
Yes.
Which is perfect. So I customize everything with Java code. So now how the btrace thing communicates with the agent?
Well, it kind of btrace lives inside the agent, so it's btrace agent.
No, I mean, the binary. I study binary, but the binary, if I start it from command line interface, it has to know that there is a JVM process.
Right. Well, so there is this possibility of dynamic attach in Java. So how it's called? It's JStat. Basically, Java will
JStatD.
JStatD is like for forwarding to other machines. But internally, there is like when you start Java, it will create kind of shared buffer in TMP somewhere where it allows some other parties to communicate to the running JVM that I want to start this particular agent, and it will grab the agent and it will load it into the memory space of the running JVM.
So this is basically this TMP is what you see if you start, JVisual VM. There's also all the processes are found, by this hack or Java feature.
It's Java feature.
Yeah.
It was really cool Java feature. It was really like kind of magical. It's going to be actually, unfortunately, this is going to be guarded by JVM flag. So for anything after Java, I think 22. You will have to specify that you are allowing the dynamic agents to be loaded, which will make life for tools like btrace or Visual VM or anything else relying on being able to load the dynamic agent, the target process quite difficult because then.
So if you launch the btrace binary, so this is exactly what happens with making Sandbox, right? So everything is more and more Sandbox. But if I launch the btrace, I can also specify port, what I see. But if I don't specify the port, it will look in the temporary folder for JVMs and will connect to the JVM, right?
Yes. So you need to specify the PID of that. And then it will, like btrace client is using unofficial APIs for doing the dynamic connection. Yeah. But it's still there. It's in some packages. So it will load the agent, and actually it will tell the agent like at which port to start the communication socket. By default is I think it's 20,
this is what they're doing.
Yeah.
So I could run with J-command, find, with J-command my Java process, I have my Java PID, then I can run btrace, and this port tells to the agent which port to open, right?
Yes, and then it will open that particular port. So you can actually, that's because if you try to run btrace for multiple processes, you need to have like different ports, right?
If when the agent is running and I say btrace, all methods Java, so I say, can I then later say a different script, or I have to restart the process? You know what I mean? So can I?
Yes, there is a possibility. Like you can run the btrace agent with the server enabled or disabled by default. If I remember correctly, it's enabled right now. So it will open the socket server, and it's listening on the particular port, and it's kind of like remote command. Like you can keep on sending commands there. So you can connect another time, and you can tell that server, I want to use this script, and it will actually start the script, and it will start sending back the data. So this is possible, but you can also tell btrace to start in like non-server mode.
No, what I mean is, can I, if the system is running, so I send the all methods, script, and then I decide I need more or different. So I can tell btrace to send or to use another script.
Yes.
So this is very interactive. So this is because it's not one shot. I can, if the agent is running, I can modify, like in dtrace actually. I can modify, the configuration. I can say I'm interested now on this method and this method. Which is actually incredible. It's not obvious, because if you're talking about point cards and AOP, how it usually works, you get the hooks at build time.
Yes.
And in btrace, you are doing this at runtime.
Yes.
But this is huge.
Yep.
This should be the feature, because I try to explain what is actually the difference between btrace and, let's say, JVisual VM. Because the instrumenting mode, they are also modifying their code, but they are modifying the business code, and they implementing like I would say proxy pattern or decorator around around the classes, I would say, right? And if someone calls the business code, they know that it's called.
Yes.
Yeah, but the code is and then you launch it, and I think then it's over. It is impossible in JVisual at runtime to change it, right?
Yeah, you can change. Well, not sure if JVisual VM, not sure if the UI allows it, but the engine itself, which is coming from NetBeans Profiler, it was able to do the modifications. So you could change. Yeah.
So what I'm searching for, what is why you call btrace a probe engine and not a profiler?
It's not actually it's not profiling, or the profiler should be collecting some performance data. So and btrace is not doing that out of the box. Btrace is kind of it's something which might allow you to write some kind of profiler. Probably, I think I have a sample script which is using it's basically instrumenting profiler, just inserting the code at the method start, method exit, and then timing it.
Exactly.
But it's not the main strength, I would say. Like in btrace, you really it allows you to build. I would say not really whatever, but in the limits. Like you can build yourself like ad hoc logging solution on top of btrace, something like with AOP. But like, let's say, actually, I have like old story. It was at one of the Java ones, and we had some issue with the Visual VM because we were going to demo it. It was pretty new, and we used btrace to actually add the logging into places in the JDK where there was no logging, so it was something was happening in swing classes somewhere, and we actually found a bug in the swing with that. So that's the strength. Like you can put a custom logging in places where there is no logging at the moment when you wrote the application. And the good thing is also that you will be running with the logging only during your investigation. Then you disconnect, the logging is removed, so you go back to like full speed of the execution. So that's pretty nice.
So you can also remove the instrumentation
yes,
in the running system.
Yes, but by default, when you disconnect from the application you started the probe for, the probe will be unapplied. It will be removed. So
this is really like dtrace. I thought this is like a btrace, but it is really behaves more dtrace. It's more like instrumentation and operating system. So for me now, for Java developer, what btrace is a toolkit to add hooks to existing code base at runtime, right? So this is
yes.
Yeah, and one very specific use case would be profiling. So with the profiling, it will measure performance. But this is I could, for instance, on the fly, add some logging code for audits, or I can provide some checks and for debugging purposes. You can say if the parameter is null, then throw an exception, and I see what happened in the system, right?
Yes.
Yeah,
exactly.
So this is actually a unique tool, btrace. Something similar?
Actually, Byteman.
Byteman, okay.
Byteman, and it was started in Red Hat, I think.
Exactly.
And I think it's Andrew Haley is, or Andrew Din. I'm sorry, guys. I'm mixing up Andrews. But it's similar. It's similar that you can define actually the interception points, but it's not using Java. It's using more declarative language. So I would say in a sense it's less powerful, but
Andrew Din,
yes. But it changes I would say the learning curve, and maybe also the complexity of the implementation is changed for the powerfulness. Like in btrace, you can do literally anything. There is by default, btrace is running in something called like safe mode or trusted, untrusted. And that means like you cannot use many Java constructs. Like you cannot use for loops, you cannot create new instances, you cannot do synchronization in the probe definition. And this is because btrace in this like untrusted mode is trying to make sure that you are not going to kill your application by accident. And this is enforced at the compile time. So the btrace has its own compiler, which is like looking through the AST and making sure that nothing skips these restrictions, also at the runtime within the limits. But if you are really sure what you want to do and you are okay with the potential instability, you can turn on trusted mode, and there you have like full power of Java. Like you can do whatever you want. Like you can rummage around the class. You can access the private fields. You can do reflection. It's like, and I don't think the Byteman can do this. But on the other hand, it's like you get the guarantee with Byteman with the declarative language. You get the guarantee that you have only these things will be happening. So
I think Byteman is heavily used in JBoss and JBoss ecosystem.
Yes.
And btrace for me is a little bit lower level. Seems like always was, right? So
Actually, btrace was used in Glassfish.
For what?
Ago. For the Glassfish had their own like dynamic probe thingy. I don't know if it was removed in Pyra or not. way back. I know. I worked with the Glassfish folks on adding this. So you were able to add some like custom instrumentation in Glassfish directly.
I just took a look at Stack Overflow. There's still information about Bitrace and Glassfish.
Yeah, really.
Yeah, Bitrace with Glassfish web container found an issue.
Yeah.
In exactly enable monitoring in Glassfish. There is a command, and it dtrace. No, Bitrace. They have Bitrace and dtrace,
yes.
both.
Yeah.
So there is a command enable monitoring in Glassfish. Actually, I used it a lot, but I never knew that it was Bitrace behind that. Because what I created a project called Lightfish. And what the Lightfish did, it is a very simplistic one. It just, it gathered all the EGB content, HTTP service, JDBC connection, pool monitoring stuff, and displayed it with JavaFX. And in order to make it work, I had to enable monitoring.
Yeah.
And it used Bitrace behind the scenes, which I didn't do. So back then. Do I get any statistics from Bitrace out of the box, or is just I get nothing? So for me, you get just the toolkit, and everything else is an example, right? So I get the idea. I can hook wherever I like, but everything else is an app or an sample, right?
Yeah. Yes. Currently, yes. Well, there is something. There is an attempt to do how it's called. Basically kind of histogram, but yeah, you can use it, but I'm not really happy about that anymore. Like there are more performant implementations of histogram out there. This is really like a trivial thing where the data is pushed into a hash map basically. But I mean, when you use this trusted mode, you can import things like how it's called. There's really cool histogram implementation out there. It's open source.
From the garbage collector, the GC viewer.
No. I mean, it's like. Basically, you are putting values into HDR histogram. That's called
HDR histogram. Okay.
HDR histogram, and it's basically that would give you like you could theoretically collect the execution time of the methods, and you could be putting them into the HDR histogram, and then you would get really nice like representation. What is your like P99 of your particular request? What is your mean? Like all the basically it's for quantiles. But
hey, whatever you mention, 2,000 stars on GitHub, whatever you mention is golden here. Lots of perfect Java projects here.
Yeah.
This is HDR histogram on GitHub, and the name of the organization is HDR histogram as well.
Yeah.
And so if you understand Bitrace, you also understand the instrumenting Java profilers because they are very similar, right?
Yes.
I mean, this is what they are doing. What they could even use Bitrace, and then they have like statistics backend to gather to have a better information, right?
Yes. Yeah.
But what's a little bit similar is JFR, right? This Java Flight Recorder.
Yes.
I would say because they are also able to emitting events on specific events on specific events, right?
Yep.
So what is the main difference between Bitrace and JFR, Java Flight Control? Java Flight Recorder and Java Mission Control.
Yes.
Yeah.
JFR has like unsurpassingly good implementation of the serialization. Like the JFR format itself is really nice, compact. It's well thought out. Unfortunately, it still hasn't been made public. But Gunnar Morling made a really good reverse engineering, and he wrote a blog post with all the details. So whoever is interested in the JFR format should go to Gunnar's blog and read it. It's
Gunnar is really a capable guy because we had him on the podcast, but he was also the lead of Debezium. which is the Kafka, how to call it, CDC tool to export data from relational databases to Kafka.
Yeah.
And this is, Kafka really well. So this is the great story.
Yeah. And the serializer is blazingly fast. Like JFR, like internally JFR is storing all the data in the thread local buffers. It's done. It's happening in the native space. So and then it just dumps it onto disk. So it's much faster than what Btrace does. Btrace is
sure, because I don't know whether you remember the JFR was shipped or came with a JRocket.
Yes,
which was Swedish too, right? And the great insight was they gathered the entire metrics and monitoring in real time. Yep. They need them.
Yep.
And the Java Mission Control was just a view of the metrics.
Yes.
And they merged with Sun's JDK, and then they merged the inner workings.
Yep.
And then point of time, this JDK from Sun or from Oracle was capable of doing that. So what JFR is doing, they are just gathering the metrics anyway because they need it for optimization of the garbage collector, to my knowledge, right?
Yep.
JVM.
Yep.
And they are just dumping everything almost like a Kafka to a memory, and then asynchronously reading that, right? So this is about JFR, my understanding.
Yep. Mm-hmm. And then you load it. You load the JFR recording either in JMC or now you can do it also in Visual VM. It also has a JFR visualizer and
JFR view command line
also
as well,
JFR
I think,
command line. It was it was extended with quite a lot of options quite recently for 21. Like you can basically write like command line analysis of the JFR. It's nice. It's nice.
But it's similar, right? Because in JFR I have to specify when event happens. And in your case, I'm injecting a hook.
In JFR, you need to write the event in your application. So you need to know that you will be emitting the event.
Yeah.
Well, good thing is I wrote the integration for JFR into Btrace. So now you can directly from the probe. Well, it's not entirely my achievement because JFR guys, they did a really great job and they added a public API where you can create a dynamic event. So in addition to doing the annotation-based event, which is more like user-facing, you can build the event entirely dynamically from your application from Java code, calling the methods. And I'm using this in a Btrace where you can specify your own event type in the probe. In the script file, and then you can emit this from the hooks, like when you. So that's pretty easy, and you can use it instead of the built-in print line command, which is doing this textual presentation. So you can just define the event type you want to have, and then you can push the data into the event. That will take advantage of the JFR super serialization and everything, and then you have visualization tools for free. You open it in.
So what I understood is that you can have now the Btrace as always, and you wrote a bridge. So a Btrace hook can generate or emit JFR events, and the cool story is now I can use the standard JFR tooling to read Btrace or to analyze Btrace code. So this would be a perfect case for to write a small profile or whatever, right? Because then I have the JMC actually, which is already great. I have a Btrace very very capable, and so my understanding is so JFR for me was always almost like a business monitoring. I can create my own events, additional business events which are emitted higher level, and Btrace is more lower level diagnostic tool, right? So but I'm surprised. Actually, it is really great, I have to say. So this is and I thought it was a little bit higher level, but this is very comparable to Btrace actually.
Yeah, at the Java level, I would say yes. Yeah.
Yeah, sure.
And Yeah, actually, I added one thing when I was working on the JFR integration. I realized that it would make sense to actually just fire up the probe and let it running while you disconnect. So I added something which is called unattended mode. So now you can do like you just send the probe to the application. It will do the instrumentation and it will start generating JFR events, and you just immediately disconnect. But it will keep on running that. Then you can do like the second, third, and basically you can build up with this like JFR event generating suite. There is some small support there where you can, from the command line, you can list all the processes with running JFR B-trace probes. So you can like reconnect to that particular probe, and then you can, for example, terminate it if you want. So, and I tried this on the Kubernetes instances over the SSH, and I was quite surprised that it was pretty easy. Like you can just execute the command for btrace over SSH on that machine, blah blah blah. You send stuff there, and you just left it running there, and suddenly like.
But you had to install the agent, right? But agent was already
installed. You need to install the agent, or you can do. I'm having the btrace on SDK man, so this is a really nice tool to manage the runtimes and everything. So you can always get the btrace, the latest btrace from the SDK man. So you can have just like you can build the image like in the Kubernetes. So you can build the image with the btrace, and then you can. And that's it. Like it knows where the btrace is living there, so you can do the SSH command. And since in Datadog we have, or I had these instances, they were integrated with the continuous profiler where we are already collecting the JFR. So I was able to immediately see my additional JFR events in the profiles we're collecting. It's just pretty cool.
Yeah. Have you ever tried to say, just do everything? So I create a script, JavaScript, star, and start, a small application like Quarkus, with Hello World. Any chance that it will succeed or will break? I mean, how much, traffic?
It should succeed for Quarkus, for small application. Well, there is a hidden dirty secret there that even if you do star, a large portion of the JDK classes will not be instrumented.
Not a problem. I mean, maybe they are not that relevant, right?
Probably, unless you want to really see, I don't know, really the collections or. But the problem.
No, I'm more interested in lazy mode, right? In lazy mode, I just do star and see what happens, and then I will restrict. Is it viable approach?
It's viable approach for something which are not if you have kind of testing environment or staging, there will be a lot of instrumentation going on. So startup will take 30 seconds, minutes. Then you will go into the warm up again, because when you do instrumentation, it will be kicked out from the C2. You will go to internal. So you will get some latency peak there. But if it's for testing, staging, whatever, that's fine. In production,
because then I can refine, right? I see what comes out, and then I can refine and I can iterate towards production environment.
Yes.
Yeah, cool. Anything we forgot to mention? I think we covered profilers pretty well. This was a side product, and I think a deeper understanding of btrace, right?
Deeper understanding of btrace. And there's actually, when you rummage around the GitHub project, I think I put there a small tutorial for btrace. It's
There's a wiki. You mean there's a nice wiki where running btrace in detail, for instance. This is the quick start with btrace.
There should be a PDF file or a markdown. Well, I will check it. So at one time when I worked for the other startup in the big data observability profiling, Unravel, I think I mentioned in the previous podcast, So together with Shivnat from that company, we came up with the tutorial. So he used that for his students, and then he kind of approved the open sourcing of that. So it should be there, and it's
There are docs. This is what we have. This bitrace tutorial
yes,
MD
that's it.
Markdown. Bitrace tutorial, bitrace 222 Hello World, and there is it is in the docs section on GitHub
Right. Yes. So that's it.
with lessons and
Yes.
everything. So this is actually. I will also put it to show
Yeah.
notes.
Yeah, it even contains the custom JFR events. It's still it's missing like packaging story. So also for that particular startup, I added bunch of packaging modes where you can basically create your like distribution of btrace together with the scripts. So you can put it onto your server. Like we had the scripts for Spark, for Hadoop, for this big data things, which were dynamically chosen. And you can do it. You can do the same. Like if you want to like prepackage everything, and yeah. But I need to add it there.
Perfect. So thank you a lot. It was a blast. And what's interesting, right? So with my Airhacks FM podcast, I'm able to speak, to the Java 1 rock stars. And back then you were on stage, telling us about bitrace and whatever. And now, every rockstar is a human.
Yes.
This is actually a nice
Yes.
story, right? And but still amazed, about your deep knowledge about Java. And and Java is still going strong. I would say Java 21 huge release. And it is getting nicer and nicer. This is actually a cool story for me because I'm always looking forward to the new Java version, to the Java release, and this is like a small Christmas, So it's like, hey, cool, and now I can do this. It's interesting.
Yeah, it's really nice. It's really nice to see all the improvements in Java, and people are still going, Java is dead and it's not a cool language. I mean, yeah.
So we hear this for 10 years already, or 15.
Come back in 10 years and then we can talk.
Yeah. Thank you a lot. It was a blast, and see you next time.
Thank you for having me here. Yep.